Right, we're on 3-2, characteristics still, and we're just on this last example 2. So example 2, it says graph a possible polynomial function. So possible, right? We don't know the specifics of this. It's going to be a little bit vague. It might not be right. You already might know it, but it's a possible. Okay, so a possible, knowing the characteristics that we know. So a possible polynomial function that has a range where y is less than or equal to 10. As soon as I see that it has a range less than or equal to 10, based on the lesson that we had before about all the characteristics we know, as soon as we know that there's an upper bound or a max, right? We know that there's a maximum or an upper bound. That's what that's saying. It's less than or equal to 10, which means there's a maximum or an upper bound. We know, therefore, that it's even degree. Okay? It's not an even function. Remember, even and odd we already covered in chapter 1. Even means that it's symmetrical around the y-axis. Odd means that it's symmetrical when you flip it twice, right? Vertical and horizontal. So odd, even. It's an even degree polynomial function, right? So even, odd was already used before, but it's even degree. That's what we know. So we know it's maximum, and it's an even degree, because only even degrees have a max or min, right? Odd degrees do not have a max or min, so that's what we know already. So in my brain, I go, oh, I know something. What's it ask me? 3 turning points. Okay, so graph it. I can graph that. I can do something that's even degree with 3 turning points that has a maximum at 10. Okay, I don't care where the maximum is. You do not have to force it to be on the y-axis. For some reason, people are always like, it should be right there. Never said anything it had to be on the y-axis, so you're just going to draw something with a maximum of 10 with 3 turning points. A turning point is where it's going, heading in one direction and turns around. So increase to decrease or decrease to increase. So you're going to do 1 up, down, and turn. 1 turning point, 2 turning points. I need a 3rd turning point. This max would be 10. I don't care where you put that. There are different variations of this. All I would be looking for is that there's a maximum at 10 and 3 turning points somewhere. Your graph has to be a smooth polynomial function. It cannot be, so like what I'm saying is quadratic, right? Quadratic is one of the polynomial functions. It cannot have any extra wiggles. There's obviously no asymptotes and stuff like that happening, but don't have extra things happening, because the more extra you have, the more you're saying something about the graph. So don't do an extra squiggle in here unless it says that there's supposed to be. So 3 turning points, we're not going to add anything unless you think there's something else. We'll get to some examples where there potentially could be something happening, and I'll show you what that means in a minute. Okay, but here it just says 3 turning points, maximum here. Don't get fancier than that, right? Don't go, oh, I think I want to add a, no, because then you're potentially going to draw too much and make it wrong. Okay, so 1, 2, 3. All right, opening down with a maximum 10. So that's all it's saying. This could have gone lower. This could have gone higher. Okay, and made that the maximum 10. I don't care as long as I have a maximum of 10 and there's 3 turning points. Again, nothing fancier than that. Try not to go too complicated. Okay, what do we know about the equation? The equation, not the graph, right? We already did the graph. What do I know about the equation? I know for sure that it's an even degree. Okay, we already know that. So what do we know about that? We know that it's an even degree for sure. What else do we know about the equation? Well, we said here that it opens down, right? So if it's opening down because it's a maximum, then the leading coefficient, right? The leading coefficient, you can use that as a short form. Leading coefficient is negative, right? The leading coefficient has to be negative because it's opening down. Okay? What else do we know about that? One more thing. Yeah. Nope, not for the equation. The equation, that the graph will use the upper bound, but for the equation, what else do we know about the equation when we write the equation? Yep.
The degree is 4.
The degree is 4 because there's 3 turning points. Or could it be higher than 4?
Could be at least 4.
At least 4. Okay, we already said even, so you don't have to say even again. So we know it's 4. It can be at least 4. It could be 6. Can it be lower than 4? No. It can't go lower because I said 3 turning points. So the turning points would be 1 higher than whatever that is, right? Or 1 lower than whatever that is. So if it's 3 turning points, the degree is 4 or higher. Okay? And again, we know about the even and odd. So if there's an odd number of turning points, it has to be an even degree because that's the only way we can draw it, right? And if there's an even number of turning points, it has to be an odd degree, right? So one more time. So if we said that I was turning it 1, 2, 3, 4, 1, 2, 3, 4 turns, automatically that means it's odd degree, right? Because 4 turns, 1, 2, 3, 4 has to be odd degree because you're facing opposite directions, right? And an even number of turns would be, right? Even number of turns is odd number of turns has to be even. Yes?
So if the degree is 2, would it be odd? Like, sorry, if the degree is 3, it would have 2 turning points?
2 turning points or fewer, yeah.
Okay.
Yeah, 2 or none, 2 or 0, yes. Always less, yeah. So this one here, if I have 4 turning points, the degree would have to be 5, yeah, exactly, 5 or more, okay? Does that make sense? So those are turning points from yesterday. All right, so then we got that there, and that's it. Okay, so that's the 3 things we know about the equation. That's why I underlined equation. You don't want to describe the graph again. We're describing what happens with the equation. The degree is 4 at least, leading coefficient, and even degree. So whenever we did the diagrams, it was always leading coefficient and degree. I use LC here. It's my own short form because this is my rough work. When you're writing an answer, maybe write the word leading coefficient, right? Because otherwise LC is not an actual standard form for leading coefficient. That's just for me when I'm writing it short form here. I go, oh, LC is my leading coefficient. When you're giving an answer, write some words, write some letters around that, right? Because it's not a short form that everyone uses. Degree is 4, even degree, all that's good. So that's all we know. Okay? All right.